Hello and welcome to this presentation. My name is Raiymbek Jangassiyev. Currently, I am a master's student in Department of Information Systems and Modeling at Aweziv University. And today I will be presenting my research titled Comparative Analysis of Cross-Platform Development Methodologies, a Comprehensive Study. I am excited to share the key findings and insights from my study, which I hope you will find valuable and informative. In rapidly evolving technological landscape, the demand for seamless and intuitive user experiences across a multitude of devices has never been greater. Gone are the days when mobile app development was solely focused on smartphones and occasionally forays into tablet applications. Today, the spectrum of app-enabled devices spans from Internet of Things, gadgets to autonomous vehicles, underscoring the need for adaptable and versatile development solutions. Traditionally, native app development has been cornerstone of mobile application creation, offering unparalleled performance and user experience tailored to specific platforms. However, the native approach isn't without its limitations. Chief among these is the inherent platform dependency of native app SDKs, which necessitates separate development efforts for each platform. For instance, iOS and Android SDKs are distinct entities, making it technically challenging to create a single app that seamlessly run across multiple platforms. In response to these challenges, the emergence of cross-platform development frameworks has revolutionized the app development landscape. These frameworks, such as React Native, Flutter, Xamarin, and the innovative .NET MAUI, offer developers a compelling alternative by bridging the gap between native performance and code resizability. By enabling developers to write code once and deploy it across various platforms. Cross-platform framework empowers them to sculpt unparalleled user experience while maximizing development efficiency. Cross-platform development encompasses the diverse methodologies aimed at creating applications that seamlessly operate across multiple operating systems. The selection of appropriate approach is contingent upon specific project requirements, the proficiency of the development team, and the desired performance standards. This paper provides a comprehensive breakdown of the principal type of cross-platform development. This table presents a comparative analysis of various types of app development, including native app development, hybrid app development, progressive web apps, cloud-based app development, and low-code, no-code platforms. As we can see from the table, native app development achieves native performance and user experience, but requires code, reuse, and expertise. Hybrid app development provides moderate performance and user experience with some limitations, and has a faster initial development type. Progressive web apps have lower performance and user experience that depends on their implementation and are the fastest option to develop. Cloud-based app development has variable performance and user experience that depend on platform and has a moderate development time. Low-code and no-code platforms have variable performance and user experience and offer fastest development time. This table can help developers to choose a suitable framework for app development. Let us now embark on an exploration of specific examples that underscore the potency of cross-platform development facilitated by frameworks. First of all is React Native. Endorsed by Facebook, React Native harnesses the proofs of JavaScript and React, thereby endowing a sense of familiarity for web developers alongside access and expansive community. Noteworthy applications developed with React Native include Facebook, Instagram, and Bloomberg. Flutter, developed by Google, utilizes Dart for rapid development and integrates hot reloading functionality, making it conducive for complex projects. Its extensive widget library and robust performance have garnered favor from notable companies like Alibaba, Reflectly, and Google Ads. Xamarin, owned by Microsoft, leverages C# and integrates seamlessly with Visual Studio, appealing particularly to .NET developers. Pinterest, Uber Eats, and Microsoft Office Mobile are among its distinguished users. .NET MAUI, spearheaded by Microsoft, utilizes C# and XAML to extend its reach across Android, iOS, macOS, and Windows through a unified codebase. Benefiting from the strength of .NET and Xamarin communities, .NET MAUI promises native level performance and appealing to both existing Xamarin developers and new ventures like. This figure shows the usage of cross-platform mobile frameworks by software developers worldwide from 2019 and to 2022 in bar graph. As we can see from the figure, Flutter usage has consistently increased from 30% in 2019 to 46% in 2022. React Native has also increased, but not as significantly, from 42% in 2019 to 48% in 2022. Cordova and Ionic have declined over the years. Xamarin has remained relatively stable with slight fluctuations, while Unity, NativeScript, and other less common frameworks have lower percentages but are still included in the data. It is imperative to recognize that selection of the optimal framework hinges upon the prices requests of your projects, proficiencies of your team, and target platforms. And identifying the ideal framework for your project hinges on its unique requirements, but understanding usage trends and performance can provide valuable insights. This table presents a comparative analysis of 4 mobile app development frameworks. As we can see from the table, React Native is ranked first in terms of usage, followed by Flutter in second place and Xamarin in third place. .NET MAUI has not yet established a usage rank. React Native has largest developer community, while Flutter has large and growing community. Xamarin has an established community, while .NET MAUI is newer technology with a developing community. It is worthy noting that these technologies are supported by the large .NET community. React Native uses JavaScript, Flutter uses Dart, Xamarin uses C#, and .NET MAUI uses both C# and XAML. And this feature is an implementation of the game of the life for .NET MAUI. The game of the life is a cellular automaton invented by mathematician John Conway in 1970 and popularized in Scientific American. Using information provided in figure, this analysis examines the performance of the .NET MAUI framework. The memory usage remains stable at approximately 230 megabytes, indicating that the game of life program doesn't consume excessive memory and is well optimized in this aspect. The CPU usage shows minimal spikes, suggesting that the .NET MAUI framework handles processing efficiently, ensuring smooth performance without overburdening the CPU. The game of life program demonstrates that .NET MAUI framework utilizes memory and CPU resources efficiently. This suggests that .NET MAUI could be a reliable choice for developers seeking optimized performance from their application. To enhance the study informativeness, The application was executed on the Android platform. This figure illustrates the performance demonstration. This analysis presents the performance of the .NET MAUI framework on the Samsung Galaxy S21 Plus device. The CPU usage is relatively low at 26%, suggesting that the Game of Life program isn't overly taxing on the device processing capabilities when run on the .NET MAUI framework. The GPU usage is also low at 10%, indicating the application isn't demanding in terms of graphical processing. This could be due to the efficient rendering or minimal graphical context in the application. The application uses only 5.97 megabyte of memory, which is relatively low and indicates that it's not consuming excessive resources. This suggests that the .NET MAUI framework is an efficient option for developer who wants to optimize their application's performance on mobile devices. And the next figure is an implementation of the Game of Life for Xamarin Forms. Based on the data presented in figure, the performance of Xamarin framework can be analyzed as follows. The program consumes 68 megabytes of memory, indicating that it is well optimized and doesn't consume excessive memory. The CPU usage is near 0%, indicating the Xamarin framework handles processing efficiently, ensuring smooth performance without overburdening the CPU. The Game of Life program demonstrates the Xamarin framework uses memory and CPU efficiently, indicating that it could be a dependable option for developers seeking optimized application performance. To improve the study compressibility, we executed the application on the Android platform. The performance demonstration is illustrated in this figure. Figure represents the data on the performance of the Xamarin framework on the Samsung Galaxy S21 Plus device. The CPU usage was found to be relatively low at 13%, indicating that the Game of Life program doesn't heavily tax the device's processing capabilities when run on Xamarin framework. The GPU usage was at 6.7%, suggesting that the application isn't graphically demanding. This may be a result of efficient rendering or minimal graphical content in the application. The application total memory usage is 5.14 megabytes, which is relatively low and indicates that it's not consuming excessive resources. This is a positive sign of optimization. And the following table displays the test results for Samsung Galaxy S21 Plus device. As we can see from the table, the CPU usage of .NET MAUI is higher than that of Xamarin, which suggests that .NET MAUI is performing more computations or processing in the background. The GPU usage of .NET MAUI is higher than that of Xamarin, which may be due to more extensive graphical rendering tasks. Additionally, the memory usage of .NET MAUI is slightly higher than that of Xamarin, indicating that .NET MAUI may be using more resources for its operations. Finally, the evaluated four frameworks for app development like React Native, Flutter, Xamarin, and .NET MAUI. This table illustrates their differences in terms of performance, user experience, development time, and other features, using examples of well-known apps built with each framework. The table also demonstrates that each framework has its advantages and disadvantages, and that there is no ideal solution for development. Developers should select frameworks that meet their requirements and preferences. To wrap up, this research has highlighted the key consideration in developing cross-platform mobile applications, providing insights into the strengths and weaknesses of different methodologies and tools. Thank you so much for watching. If you have any questions or would you like to discuss this research further, please feel free to reach out to me. I hope you found this presentation useful and appreciate your time. Goodbye.